Okay, Baruch HaMaboim, it's more than a month that I didn't give any shiurim, so I would repeat some stuff, and please forgive me for repeating. I think it never hurts to repeat. We are discussing here the inyan of Ma'agal Yereach. Ma'agal Yereach, the Rambam, it talks about it, and we're going to give an introduction. We probably spoke about it, so I'll repeat it again. It's also another method is getting from Eirich Sheni to Eirich Shlishi. That's another way. The Magal Eirich is a certain number that you use to add or subtract from Eirich Sheni, and you get Eirich Shlishi. What is Eirich Sheni? Let's review. Eirich Sheni is the longitude of the moon. Longitude means the ecliptic longitude. As we said, that when we discuss the moon, we use ecliptic coordinates. So we use the system that has to do that. It has with the teleh. That's how it starts 0. Then it goes to the next mazalas 30, 60, shor to and so on. That's the celestial equator. We use that as the center. Then we have the latitude of the moon. The highest latitude can have 5 degrees above the ecliptic or 5 degrees south of the ecliptic. That's the latitude, and other stars can have a higher latitude, but this is the highest the moon can go. The farthest away from the ecliptic, north or south, is 5 degrees. So when we figured out, up to now, we figured out where the moon is. It means what's the ecliptic coordinates of the moon, and from now on, we will give them a shortcut: longitude and latitude. Longitude, you always have to think it means the longitude of the mazalas, and latitude is the roichav, as the Rambam calls it. That's the north or south. So we have in our pocket here the we figured out, after making the Shinui Mara, we discussed it at length, we finally have a number. Let's assume we have the number 30, making very easy numbers. 35 means the longitude of the moon is 30, the end of the le, and it's 5 degrees above the ecliptic. So what is our goal here? What's our objective? So Rambam says what we want to do is, I explained it, and it needs some insight to chap what we're trying to do here, because it sounds very awkward, so we really have to put our heads into it. So there is also another system of coordinates that's called right ascension and declination. That's a different system that uses the celestial equator as the center, and then we have the north celestial pole, south celestial pole. And then we have the right ascension. Right ascension is the same concept of longitude, just we name it right ascension. So we can have 30, 60 right ascension. And then we have declination. Declination means how much degree a certain star or object is above the celestial equator or below the celestial equator. So basically, we have here two coordinate systems that we can even view it like overlapping. You can picture in your mind, you have this grid system, one on top of each other. I'll show soon a two-dimensional way of trying to show it. But try first to picture yourself. You have let's say a ball, a sphere, and you have lines passing from pole to pole with the center of the equator, and overlapping on that, you have another grid system that has the ecliptic that's 23.5 degrees inclined towards the celestial equator, and then you have ecliptic pole, an ecliptic south pole, and then you have the lines of that go down from pole to pole. That's the dividing that making the longitude, and then you have the latitude. As you go up, you can make 10 degrees or 15 degrees divisions from the ecliptic till the pole. So that's it. You have two systems, one grid on top of other. Okay, so what are we doing with this whole thing here? So here's where what we want to do. We want to take we want to find the point on the ecliptic itself. The ecliptic means that it has the latitude of 0 that shares the same right ascension as the point where the moon is. So in this case, the moon is on 35. It's 30 longitude, 5 latitude. So we can ask an interesting question. Obviously, it has a certain right ascension and declination. There's a way how to figure it out. Let's say we find the right ascension and declination is 27, 15. Okay, so we would like to ask a question. What point of the ecliptic of the Galgal Amazalas has the right ascension of 27? Every point on the ecliptic has a different right ascension, obviously. And there's a certain formula how to calculate that. I'll show a lot of graphs to explain this, but first I want you to get the core concept here. So we want to take that right ascension, that imagine you have a computer that spits out for any given ecliptic coordinates, it spits out the right ascension. So you type in 35, it spits out the number, right ascension, declination. Now, declination we're not interested in now. But let's say it spits out that the right ascension of this point is 20, 27, 28. Let's say 28. I think it's more close to 26. Let's say it spits out 26. Okay. Now we're gonna look on the ecliptic and see which point on the ecliptic has a right ascension of 26. So we can do it by brute force, just checking every point of the ecliptic. Let's say we have a computer, we can type in every single point of the ecliptic till we see, oh, this point is 26. Oh, we found the lucky point. We're looking for a point. Now that point on the ecliptic will not be the same. It's not going to be 30, obviously. It's going to be different. So let's say it's going to be 27 or 28. So the difference between 30 and 28, that's 2, that's called Magal HaYerech. The change that we get from 30 to 28. Because we want to find which one has the same right ascension, so it's a different, it has a change because this is on the ecliptic itself, that's 5 degrees above the ecliptic. So we need to find which one has the right ascension of 26, and we figure out that the point on the ecliptic would be 28. Again, so we start with 30. I have 3 numbers here, not to get confused. We start off with 30. 5, yeah, the latitude is 5, 30 is the longitude. Okay, we started off with 30. Next, we found out the right ascension. We saw the right ascension of that is 26 of that specific point. Now we're going to check on the ecliptic to see which point on the ecliptic has a right ascension of 26. And guess what? We find out that the point 28 on the ecliptic has a right ascension of 26. So we say, oh, this is the lucky point. This is called Erech HaShlishi. And the Magal HaYerech is just that number that you need to subtract or add. So in this case, we are subtracting 2 degrees. That's gonna, from 30 to 2, that's gonna be, from 30 to 28, that's gonna be called the Magal HaYerech. So it's very important just to get the outline before you get into details. I'll try to start this video and try to blow up this thing here, so you can see something about how this works here. Okay, take a look at this graph. Orach Sheni rochav of 5. It shows if this is the orach, for example 20, and you have a rochav of 5, so this second, the y-axis, the x-axis here, the y-axis shows what's going to be the orach shlishi, what's going to be the point of the ecliptic that shares the right ascension. It doesn't say here the right ascension. I did not, because it's not important. There is a formula to take this 25, 5, get the right ascension, and then see on the ecliptic itself which point on the ecliptic has that right ascension. So guess what? 25 gets converted into 20, I can think 22, I think, something like that. So this is the Orach Sheni, Rochav of 5. It means we're dealing here by Rochav of 5 because that's when it's the most obvious. And this goes for the other from negative 90. This goes from negative 90 to 0. That's the second part of the ecliptic. Oh, here I blew up Magala Yerech. This is better because you can see more clear the actual differences. Before we saw the numbers Orach Sheni, Orach Shlishi. Here we're going to see the Magala Yerech. That's the number of degrees you need to subtract. So let's say example Orach Sheni, and again Rochav of 5. If we have an Orach Sheni that's 0, that's by Tele, and you have a Rochav of 5, it's the maximum. Then you're subtracting more than 2 degrees. So let's say you have your your latitude and longitude of the moon is 0.5. So we need to convert this. The Orach Hashlishi would be 2 degrees less. It will be 358, even less than that. That's going to be the Orach Hashlishi. Why? Because we need to subtract 2 degrees to find the point on the ecliptic that shares the right ascension of that point there where the moon is. We can see in the next video why this is so. First, we'll just believe that this is the fact. And here you see the other way around. You go from 0 till 75, negative 2, and again when it gets to 90, then it's 0. It means there's no magal. It's the same. You can just use the 90 degrees. Let's say the moon is 95, so we don't have to subtract or add. We just use 90. That's the Orach Sheni and Orach Shlishi are the same. The Rambam says that Orach Sheni and Shlishi coincide. There's no magal cloud. Let's just go one more picture. Oh, I think this is the end of this. So this is again. I'm not giving you any explanation why, and this is just telling you the facts. And you can see here that the maximum would be to subtract 2 or add 2, but that's the most you can go. And okay, in the next video, I'm gonna plan to show you on a grid that's gonna show you exactly how we can see on a two-dimensional system. You can see on the two-dimensional grid both systems, and you can get a better picture how this conversion y by 90 is nothing and y by 0 is the maximum. Okay, thank you for listening.